verification.
Hello, this is CryptoBang and this is our Python code. I'm just about to click run onto our program. We can see first it's waiting for enough data to pile into chunk 1. This is so it can begin. Enough data came into chunk 1 and it quickly verified successfully. Chunk 2 also verified successfully, and now chunk 3 has also verified successfully, and based on our parameters, the WebSocket now closed and the program was gracefully executed. The data of the verification was stored in two CSV files. The first one is the chunk data records, which is here, which shows which chunk of data it is, the timestamp of that data, the actual data size, which is a very, very large figure, the size of the data, which should be equal to the chunk size, the signature of the data, which also should be a very large figure, the outcome, and the percentage true verification of the data. So just to look through, it's a very, very large text field. So now we're going into the matrix table output, which here shows the outcome of each node. So first what chunk it's going through and what node it is. So in our test we have 10 nodes, so node 0 to node 10, and we have 7 segments for it to test, so true, false, and so on, and the percentage that this node voted true or voted false for each segment, and then the outcome of the verification, whether it was overall successful or unsuccessful, the size of the data each node received. So this proves that all nodes were equal and received the same amount of data, which was 500 bytes. The hashes, which is a very large number, the signature of the data of each data segment received by each individual node, the timestamp, and then the status of whether the node is good or faulty. It's good if it makes less than 15% mistakes compared to the overall outcome. If it makes more than 15% errors, then we say it is a faulty node. So the configuration for our code is all determined using a few constants that we have here, which are the number of nodes, for example, faulty proportion, the number of faulty nodes, the chunk buffer, the frequency to check the buffer, the number of segments, the total votes, minimum approval, segment length, number of chunks you want the program to process before gracefully exiting the data buffer, and so on. All these can be changed according to the solution needs or the business's needs. So this is our Python code. We are Team CryptoBang. It was pretty fun doing this challenge. Thank you for looking at our code.